see. Okay. Okay, so today we will start with a new topic. And basically, previously we kind of saw this concept. Okay. So what today we will learn is about generics. Okay, so here we will see, we discuss generic methods and generic classes. Okay, so we are going to discuss this concept. And if you recall previously, whenever we try to use array list, and we have this angle brackets, and then we needed to plug in some concrete class. Is it so like a string or something? Is it? And you can plug with different one. Is it a string and maybe employee, maybe book? Is it all sorts of different? Is it? So that's for array list. If you recall our queue and stack from the Java library, they have this similar thing. Is it? So basically, the array list, queue, and the stack that we learned, they are generics. Okay, so stack is a generic class. Array list is a generic class. Basically, this is an interface, generic interface. Is it? So generic kind of the idea is they provide some template. Provide some template. And then you can kind of customize. Is it? That's kind of the concept. Is it? So how do we also write our own generic method or generic classes or interfaces? That's what we will learn today. So first, let's take a look here, this example, okay. So first, let's take a look at this one, this method search. So here we have method name, and this is return type. And here the static means it's a class method. Is it? So nothing new here. And for this is parameter, we know. But over here, if we take a look, this is new. Is it? So it's not some specific type. It's just a type. And this type is some generic. It doesn't represent any specific type. Is it? So if you define a method and the method parameter has not the specific, it's some generic type. And also for this array list, over here, it's not some specific, it's just a generic type T, is it? And for this method, after the static, so before the return type, it also has the angle brackets T. And you can also use angle brackets E or angle brackets T underscore. So whatever, that doesn't matter. Okay, so this doesn't matter, but it's not some specific type. Okay, not a specific type. Then this method, basically, this is a generic method. Okay, so whenever you want to write a generic method, then you need to have this angle brackets, either T or E or whatever, some generic type, not a specific type. Okay, if you do if like the array list, if you plug in string, then that's not a generic method. That's specific type. Okay, so this T must not be defined. That it just used to represent a generic type. Then what this search method, so it can be applied to various reference type. Okay, so it's not just applied to an integer or string or double or employee. It can be anything and depends on what you call. Is it? So over here, this search, okay, it's pretty simple. You just loop through the array and then do one by one comparison. Is it? Call the equals to compare. Is it? And then see if you can find it or not. Is it? So that's regarding this search method. But anyway, the syntax here with the angle brackets, then the parameter also have the generic type, then this method is called a generic method. Okay, with this generic method, then what over here, let's see. So this V1 is an integer array list. Okay, and this V2 is a character list. Okay, for V1, it's pretty straightforward. We just add 0 to 9 to V1, is it? And then what over here is, we call that search method that we just discussed. So let's take a look. Here, okay. So here, V1, the type is integer, V1. Is it? 10 is an integer. Is it? So we call this search. Is it? So basically this T now and this T. Is it? And it's the wrapper reference. Is it? But previously we learned, is it? It can do auto boxing. Is it? So this matches. So V1, the type. So basically here, T is integer. Okay, at runtime, is it? It will be plugged in with integer. Basically over here, it's not just runtime, it's compiling time. Compilation time. Is it? T, the search method T is going to be replaced with integer. Okay, so then this search applies to your search some integer item. And then what is the next one? Try to show here. This loop add character. Is it? So V2 is a character array list. Okay, V2. So what over here, basically J is a integer. Is it? Then here we cast it. Then we cast it to the wrapper character. Is it? To the wrapper character. Okay, then we add it to the second array list. Then we do the search on the second one. Is it? So this time, this is a character, so it matches. Okay, so this time T is character. So it matches. So basically over here, we can also see why we want to use generic method. Then in this case, we just need to write one search method. Is it? But it can be applied to search any type of array list. That's it, not just some specific type. So that's much convenient. They just write one, but you can apply it to all sorts of type. So data type is not that important now. The important thing is how you complete the task, etc. So over here, so this example shows us how to write generic method. So whenever you want to write generic method, be careful, you need to add this in your method header, okay, angle brackets before the return type. And also for the parameter, you also apply to the generic type, okay. Okay, that's for this one. And this example on our course website, it's called the generic method, okay, generic method here. The second example is called generic, Java generic, okay, it's this one. The second example is Java generic example 1, okay. So we have 3 files here. We have a utility file, we have generic type, and then we have generic example 1 Java file, okay. Then let's see, let's see. So I need to get rid of this. So first, let's take a look at this one. This is utility. So maybe let's take a look at the other one first. Yeah. So let's take a look this generic type first. If you take a look at this generic type, this is a class. Okay. So over here we want to define a generic type. Okay, generic type. So if you want to generic type for the class, generic type class, then after the class name, you need to have these angle brackets. It can be T, it can be E. It can be whatever the name, okay? Like you do type, or you can do element. So all sorts of things, okay, you can do. All sorts of things, it doesn't matter, okay? So you just pick one, okay? So over here, generally speaking, we pick T, but this is not mandatory. So anyway, but you must have this angle brackets part. Then that means this class is a generic class. Because you have this generic type, so you need to have some instance variable type that's also generic type. So this T type is some generic type. The get method is pretty simple. You just return it. The set one is also pretty simple. You just assign it. Is it? Then you may ask, can I also define a, so both of this method are instance method. Is it? But there is some restriction here. Okay. So the restriction here, be careful, is that generic type parameter of a class not allowed in a static context. Okay, so this is not going to be allowed. So you cannot define a static method and the parameter is your generic type. That's not going to work. And here they explain the reason why it's not work. Because it said T is available only after instance is created. Is it? But for static method, they can be used even before instances are available. Is it? So that's why the generic type parameter cannot be read inside the static method and variables. Okay, so keep this in mind. Okay, so this is regarding a generic class definition. That we can also say it's pretty straightforward. Okay, so it's pretty similar as what we learned before. It's just the class name. After it, you need to have the generic, and the instance variable, you also need to have generic. Okay. And then for this utility class, so here we define another class called utility class. This utility class is pretty simple. It just has a single method called compare. This single method return type is Boolean. And also, okay, it's a static method. What is a parameter type? So it's just the generic type that we just defined, that generic class. Okay, generic class for the parameter. And this method is a generic method. Okay, this is fine because this class itself is not a generic class. Okay, so this class is not a generic class. Be careful. This method is generic because it's a parameter, has generic type, and over here we also identify it as generic class. And the method itself is pretty simple. Is it just the first objects compare with the second object? Is it? So this part is first object, basically its type is T. The second is also type T. And then you call T's equals method to do the comparison. Okay. Okay, that's regarding this method. Then next, let's see the driver part. Okay, for the driver part, so let's just take a look one by one. Okay. The driver part, we first create an object called G1 using the generic type, and we plug in with string. Is it? Then we can call set, and you provide a string. Is it? And over here, I can also show you. If I comment out that, is it? If you want to set with some number, then over here it report error. Is it? And here it said incompatible type. Is it incompatible type? So that's one of the benefits for generic. Is it? So it can detect incompatible type at a compiling time. We don't need to wait until the running time. Is it? It doesn't matter because here you said it should be string. Then you try to plug in with some integer value that won't be allowed. So that's why you need to plug in with string. Okay, only string will be allowed. Is it? So we know, okay. So that's one of the advantages for generic, is that it can help you detect the incompatible type error, okay. And what to the next one, the second one, generic, is also string, is it? And we can call it a set method and plug in with string type. The next one, I1 this time, it's integer. That's why when you set 100, this time it works. The type match. I2, it's also integer. So that works. So this all works. Okay. No problem. And then what next? I try to call a method called is equals. Let's see. Here is that is equal method. Is it? This is the equal method. We can see it's a class method, but here it has that angle brackets. So this is a generic method. And what it does is it's just check. It just check both parameter. The parameter is what? It's generic type class. So compare these two objects. If these two objects are the equal, is it? So it call this. So this will return whatever t, and this will return whatever t, is it? But here we compare G1 and G2. So let's see what our G1 and G2 is type. G1, G2 is a string. Is it? So G1 is a string. And G2 is a string. Okay. And we try to fit in. So the type T here is a string. Is it? So we try to call this method. When we call this method, we can do something like this. So this method belongs to this class, is it? So class name, and then dot. And you can specify, okay, the generic type matches. So the T is string, should be string. Okay, should be string. And then it works. Is it? It works. We can try here also. Suppose you say, okay, how about let me try to I. Try to I. Then did you see it will complain? Is it an incompatible type? Is it will automatically detect the error? Is it? Okay, so only this will work. Is it only when type matches with each other, then it will work. So over here just shows us if you try to call a generic method, before it, you can plug in whatever specific type. So you can plug in concrete type. Is it? It's a string. And you can also provide the name of the class. So that's one approach. And we can also call, if you recall, that compare method from that utility. Is it? So let's go back. So here is our utility class. Within the utility class, we define that compare method. It's a generic method. Is it? Okay, then over here, we try to call that method compare. Is it? And the type we plug in is also string. So it applies to G1. And you can also specify this method is from utility class. Okay. Okay, so here is how we call. And you can also, because this equal is from the same class, you can directly just call the method. Is it? Okay, so we can directly call the method. And this time you plug in with integer. And over here, we didn't specify. So that's also fine. Okay, because both type compatible. Okay. And you can also call the compare method. You don't specify the angle bracket string. There we don't provide the parameter, but this two matches. Is it? It's integer. So that's also fine. So over here, it just shows us you can use multiple approaches. Okay, whenever you try to invoke generic method. Okay, we can do the multiple ways. Okay, different option. Okay, then we can try to run this example to see how it looks. Yeah, did you see it's all runs perfectly, is it? So nothing is equal here. And for our first method, I haven't run it, we can also run it. So the first method also try to do search, that it can complete the work. Using just one search method, but it can be applied to both integer character. You can also even within main, you can also do employee search. You can also do account search. So all sorts of search, you can use that search method. Okay, so that's the second example, okay, regarding generic method and the generic class. The third one is called Java generic 2. The third one is here, okay. Is that Java generic example 2. Here we have two files, okay. One has main, the other is some definition, okay. So let's take a look here to bring this. Okay, the third one, let's take a look this time. This measurement generic. So we define a class, and this class, because we have angle brackets and we have the T, so we know it's a generic class. And generic class not just support one type of generic, because in your class then you may have different type, is it? So a lot of time then it allows multiple types. Is it because it's two different? Okay, so here, okay, this is nothing new. Then you just use comma, and this means U, another generic type. But this U is different. It said it extends number. So what does this mean? So basically, this is not just a generic type. This is called bounded generic type. Okay, so this bounded means U can be number or its subtype. Okay, it cannot be string, it cannot be employee. It must be number or like integer, double, of those. Okay, so it can be different type, but it must be subtype of number. So that's why we call this as bounded type. Okay, so keep this in mind. Because sometimes you do need this. You need to restrict it. Okay. Okay, and then let's take a look at this class. So we have instance variable type, then it's T. The measurement instance variable type is U. So measurement can only be number or its subtype. Okay, cannot be other type. Be careful here. Okay. And then this get type is pretty easy because the return type is T. And get measurement, just a return type is U. Okay. So then nothing new here. And then we also have set. It's pretty straightforward. And we also have the toString that. Okay, so not a lot of new thing here. And then let's take a look at the example. Okay. Okay, for this example, okay, how we use it. So here we define a object. So this is an object. So this object, then did you see? So this is matching the T. This is for U. Is it so string any type T? But U can only be number or its subtype. So integer is subtype of number. Is it? So that's why it is fine. Okay, and then you do new, then this. Okay. Okay, so that's for this part. And then you can set measurement set. You can call the set method. That set method. And then we just output this object. So nothing new, is it? Okay, then second one. This is an object. Okay, so regarding t, then this time it's a Boolean. Then regarding u, it is still integer. Okay, so that's still work. Okay, we can see nothing changing. For the third one, third object, okay, then the type is t, and over here the type is a float, and the float is subtype of number. Is it? So that also works. Then we can just do the set, okay, assignment. So nothing new here, okay. And then we can change. Suppose we comment out here and do this. Let's see. Then did you see here it report error? Is it type argument string is not within? Oh no. Is not within the bounds of type variable u. Is it? So it will report the error. So here it shows bounded type. Is it bounded type? So string is not number, neither is subtype of number. Okay, neither, is it? So that won't work. Okay, so we can comment, we can bring it back. Okay. Okay, then what next one? Let's take a look. So here we have some method called is ascending. Okay, so let's take a look at this. Is ascending method. This is also quite interesting. Okay, so this is ascending method is a generic method. Is it? So the parameter type is an array, but it's a generic array. Okay. Generic array. Okay, and then what over here is a generic method. So here, then it says t, is it? So it also bounded the t. The t must be what? Extends from comparable. So regarding that bounded type can also be interface. Okay, and if it is an interface, that means the concrete reference type. So basically it's just some class, is it? It must implement the interface. Okay, if that class implement that interface, then it's fine. If not, then you cannot use it. So that's what the bounded type here mean. Okay, so that's also fine here. Okay, that's also fine here. Then in this case, we are trying to see if it is in ascending order. So we are going to use arrays length. Because the T type, it's generic, is it? For generic, the T for reference type. For reference type, we cannot use greater than, less than, or equal, is it, to do comparison, generally speaking, is it? What we can do is you can call compare to from the comparable interface. That's why we always say in Java that comparable interface is also very important, because a lot of time when you want to do comparison, you need to call this compare to method, because you are not always be able to, because this only be applicable to primitive type. Is it? So then for reference type, then you need to call the compare to method to compare. Is it? So here we call compare to see if the two insequent item, this one is greater than, so this one is greater than the other one. If it is, then in ascending order, you can keep doing. If not, then you return false. That means it's not in ascending order, it's in some other order. Is that? Okay, so that, so over here, that's why we need this T to be a bounded type. The bounded type can also be some interface. What that means, just that class needed to implement the comparable interface. Okay. Okay, that's the idea here. Then let's see over here. Let's stop here a little bit. Okay. And then let's see over here. So this is an integer. This is reference type. Okay, wrapper integer. Integer. So this is reference type. And also be careful, okay, for generic type, they must be reference type. You cannot plug in with primitive type. Okay, that won't work. We got to use the reference type, even though it's primitive value, etc. Anyway, so here we have this array, integer array. Then you can plug in, etc. And this integer class, it implements comparable interface. Okay, so that matches, so the T integer, that is fine. Okay, that is fine. So you can directly call, okay. And for string, here we have a string array. And the same thing we plug in. That also works because string also implements the comparable interface. Okay, so that's why it also works. Okay, so that's the idea for this example. And we can run it to see a result. And after we run, is it? Yes, we see, is it? So we have the ascending order, is it? So it works, okay. Then let's get back here. Yeah, let's get back here, okay. And then what next? Let's see here. And here, suppose I comment out this part. And let me do this. And suppose I comment out this and then comment this. Did you see? You may ask why we need to do this extent comparable. Is it, why not just T? Is it a generic method? Then here, did you see? Here it report problem. Is it report problem? Then let's see what the problem is. Is it? It's a bad operand type for the binary operator. Is it? Because T is generic. Is it? Generic type, it's a type, it extends object declaring method. Is it? So that will not work because this one only apply to primitive type. Is it? So it won't work in this case. Is it? So that's why, okay, so if Let's get it back. Is it, even if we do this, that still won't work. Is it because that doesn't support a comparison? Is it? So you need to get back to this case. Is it? So that's how this, later on when we learn Java collection, we also see this kind of scenario quite often. Okay, so that's just some interface. Okay, you do extend, that's bounded type. That means the reference type, you need to implement this interface. Okay. Okay, so that is regarding this example. And I think let's just stop here today.